Hey guys, let's go to problem 18. So given a set of real points, x comma and a circle real. So if you get something about real value, what do? Performing casework, right? So we got to perform some casework for sure. Obviously, must be some casework. So we're going to actually use the casework right here. 3 times absolute value of x. So we got 3 times absolute value of x plus, it's going to be 2 times absolute value of y, and this will be positive 6 for sure. Okay, so let's just assume that we got 4 possible cases. Number 1 and 2 and 3 and 4. Whew, it's going to be tough. So what if x is going to be greater than or equal to 0, but at the same time y is going to be greater than or equal to 0? So what happens if x is greater than or equal to 0, but y is less than 0? So what if like x is smaller than 0, but y is greater than or equal to 0? But at the same time, what if x is smaller than 0 and y is smaller than 0? So you can check that out. The first one corresponds to the first quadrant. The second one corresponds to the fourth quadrant. The third one corresponds to the second quadrant, and that shall be the third quadrant. Okay. Let's just jump into the questions. Why not? All right, so we got 3 times x plus 2y, which is going to be positive 6. That's what has happened for the absolute value. What about x is positive, but x is non-negative, but y is negative? So here we go. We got 3x minus 2y, which is supposed to be 6. And you can also argue that we get negative 3x plus 2y, supposed to be positive 6, for sure. And you can also see that the bottom part will be negative 3x minus 2y equals positive 6. So what do you know about all of these functions? Well, we know that all of these functions are giving me some kind of x-intercept and y-intercept. So can we use one of the screens out here? So let's just try to use our screen out here. All right, so we got the x-axis and the y-axis. So we got x-axis and the y-axis. Okay, so the first one, we got the x-intercept of 2, right? X-intercept of 2 and 0, y-intercept of 0 and 3. So we got y-intercept of 3. So here we go. We got some 2 and we got some 3 out there. And the graph will only be sketched on the first quadrant. You can actually do a similar thing for the second one. Well, that's going to be the fourth quadrant. It's going to be 2, 0. But at the same time, this is going to be 0 and negative 3. Got it. So we got 0, 2 comma 0, and there's negative 3. So we're going to sketch it like this. All right, so what will happen in the third one? We get negative 2 and 0, and we get 0 and positive 3. So I got negative 2 comma 0 and 0 comma 3. So we get negative 2, and you can actually just connect those dots because that's a linear function. And we can get negative 2, 0, and 0 and negative 3 for sure. And I'm plugging x equals negative, so I'm plugging y equals 0, right? So we get negative 2 comma 0 and 0 comma negative 3, and we connect it. And all we need to do is just define the area bounded by its graph. So because those are bounded by its graph, that's going to be the area of a rhombus. So how do we find the area of a rhombus? We multiply the length of the diagonals. We multiply the length of the diagonals and length of the diagonals, which is positive 6, and we multiply with 1/2, right? And for those people who have no idea how we've done this, well, you can actually use those kind of like a rectangle that is wrapping around those rhombus. And you can see that, oh yeah, that's going to be 4, that's going to be 6, but it's half of it. So you multiply and you cross out those values, and we're leaving 3. So that becomes 12, and the answer will be 12.